So welcome. Johannes Ewald originally tried to did a talk this slot, but he got sick, so we did a replacement talk for webpack.
Yes.
So who was here yesterday for our talk in the discovery stage?
Oh, cool.
Cool.
New faces.
Thanks, you're getting it again. But it's awesome talk. Okay, we want to talk today, a short talk about 50 not well-known webpack features. So actually we have a very short, try to keep it short, not very well explained. No amazing animation, we haven't time. I did the talk in the train, so. Okay, thanks. But you will see some code samples, so it's super great. All code is the best explanation. So import. So not very well known is that Webpack 3 added a new syntax for importing, for the lazy loading. It's called import. It's covered by the ECMAScript spec and also supported by Chrome and Safari natively. And yeah, it's looking this way. You should just pass a module name to the import function, or it's kind of function, and it will return a promise which will resolve to the module or the namespace, the whole namespace of the module if you have an ECMAScript module. Also great to combine it with async functions, available, and yeah, Webpack basically takes this and split your application at this point, and you will get better performance.
Yeah, so this is something you want to use when so for example, if you're using like a Chrome coverage feature, you can see how much code is used upfront by percentage, and so code that isn't actually used on your initial render of your page, but is being used at a later time, whether it's below the fold or it's in a different route or something else, you should be using the dynamic import statement because it's going to asynchronously load any of the code until it's actually needed.
So, and the import function has some great features, some great additions that are not covered by the spec, and we try to make it backward compatible with a magic command, so it shouldn't break other things, the native support of Chrome and so. So you basically add a command with a JSON-like syntax in the command and can add some metadata to the import statement. Example, you can give the chunk a name, which is, if you want to the file name of the chunk, you better debugging, see what file is loaded, or yeah. It's also combinable with expressions. Here we used template strings to add some name or some expression-like statement into the import statement. And the magic is here, Webpack creates a chunk per each expression possible. So you get basically for every root or for every page or for every template you have, you get a chunk, and the import statement only loads the chunk you requested. So it's basically, yeah, it's cool.
Really good for performance.
Yeah.
And so this, if you're used to using require ensure, we recommend using this because then you can leverage all of the features such as the naming for the chunks. But this is also really beneficial if you use hot module replacement and you want to be able to re-request inside of the hot.module accept. I always use the import statement instead of the eager, so then it's similar.
Oh, eager? That's the next slide. Okay, there, yeah. You maybe want to have a chunk per expression, but you can opt into other behaviors. The default behavior is the lazy one, so every expression is in its own chunk, but there's also a lazy one, so it's in every expression is in one extra chunk, but it's an extra chunk. And there's the eager one, which is basically like synchronous. Yep. So it still returns a promise, but the modules are already included in the chunk you are in. So it's not doing network requests, but it returns a promise which resolves instantly. Yeah, there's also a hidden one, that's mode weak, which doesn't include the files, the modules. It rejects the promise if it's not available, and it's resolved promise if it's already available. So maybe it's available, then it's returned synchronously, or returns the promise which already resolved. And if not available, it doesn't do a network request, but just says yeah, we haven't the module yet.
That's used for SSR, right? The weak.
Yeah, it's kind of a feature for SSR. So basically, in SSR, you already have the modules available and don't want to do a network request.
That's right. And server-side rendering, if you don't know what SSR is.
So now there's a bunch of resolving features. Resolve alias is the first one. So here you can redirect module requests in Webpack. So you just say, my code base uses underscore, but Lodash seems to be better, or smaller. And you can just say alias underscore to Lodash, and Webpack will automatically resolve any require underscore to require Lodash. Also great for here we replace Lodash with Lodash ES, which is the EquaScript version of Lodash, which supports better tree shaking, so it's more optimized. Or sometimes modules have wrong package JSON with the wrong main field, or you want to point to a production version of some distribution module, so you can resolve module requests to inner modules. It's this one missing main field. And also cool is to have you don't want to have the //// behavior. So you can just say app is my root of my application. You resolve it to the root of the application. And now you can write require app / something to always go back to your root. Many people do also with a tilde, so it's just another name.
Yeah, the tilde is really common in like for Vue.js or like Nuxt or Next. They use kind of this pattern here out of the box where it makes it easier to require modules from different folders or different locations, because it always points back to, let's say, a root folder or your source folder. So this is just a simple way to make your require statements easier when you're relatively requiring them between different modules.
Yes, great. Resolve modules is something similar. So with this option, you just you set the lookup folder for all the modules in the application. So like I say require underscore, and Webpack looks it by default. It looks it up in the node modules folder. But here you can modify this behavior. So maybe you want to have your own folder with modules. Maybe you have a modularized code base, so you can just pass an absolute var to the folder where my modules are. So, and don't forget to add the default one, so npm module still works. So basically, if you pass an absolute var, you get resolving in this folder. If you pass a folder name, it looks up all the node modules in the directory tree from your relative to your require statement. So yeah, always in the parent folder, and if it's found, until it's found.
And this is useful for, like, let's say if you have a mono repo or you have like hundreds of personal packages that you want to try and resolve first. You can pass that directory and think of like a flat module, or like a flat folder of packages that you might have locally. It'll make it easier to automatically resolve those, just as if they were node modules themselves.
Yep. Oh, yeah. So resolve plugins. It's not well known, but it's well known that Webpack supports plugins, but resolve.plugins is also plugins for the resolver. So you can write resolving plugins which have custom behavior, support your legacy code base, or yeah, while migrating you can point some magic stuff to something else. So it's just to know you can write plugins for the resolver.
I think a popular one in the React community is like the ability, they kind of have the naming convention where it's like the folder name, and then because they didn't want to have an index.js everywhere, they do like name of the component.jsx. And so people have written a resolver for like a resolver plugin to basically automatically resolve that by requesting the folder.
Yes, they like to have the name of the file in the code editor, because it always shows the base name. So it looks better, but be careful with this stuff, because if you try to stick with the default resolving stuff, because you're getting incompatibility to non-Webpack stuff. If you want to, sometimes in the future maybe something else, webpack or so, it's better than Webpack. So you can't easily migrate to this. Yep, don't expect this about. Okay, output library. you can use webpack to create libraries, which is supported by this output library option and output library target option. So you can just say, that's the name of my library, mylib, and library target, there are multiple options between AMD modules, CommonJS modules, global variables, or UMD, which is kind of automatically choose the right one for you. So this just adds some header to the bundle and creates some CommonJS exports or AMD defines or the UMD header. It's also affected by the externals option. So if you have externals, they are, if you, in example, use Lodash as external, become later this, then the define function includes the dependency to Lodash.
So then that way you don't have to have both Lodash as a dependency in both places, just in your actual library code. And this, or I mean in your application code, and this library will look for that dependency to be available when you use it.
Yeah, there's the source map dev tool is well known, but there's also a less optimized dev tool. It's the eval dev tool. It's not don't have the same quality as source mapping dev tool, but it's a lot faster. So it's maybe an option for you if you don't have heavily transpiled modules or can read transpiled code or don't use Babel or something like that. Or yeah.
Something you should keep into consideration is that don't use this in production. Eval will just basically wrap your entire module function in your bundle in a string and eval it. So the size of your bundles gets considerably larger as well as...
And it doesn't minimize.
Yes, and you know, eval deops any type of code in the browser.
So there's a good table in the documentation which lists all the dev tools and if they're production ready, which quality of code they produce, if they're fast or slow, and you can look it up if you're interested. So if you like the source mapping stuff, but you don't think it's flexible enough for your case, you can, instead of the dev tool, source map, you can use the source map dev tool plugin, which is a plugin which have a lot of options. In example, you can exclude vendor chunks, you can filter by name, you can pass additional options, use another comment for the source map. It's great if you need more flexibility for the source maps. It's also for eval and eval source map dev tool. So externals. Externals basically allows you to reference modules which aren't included in your bundle, but you want to reference them from the environment. An example, you have Lodash from CDN, and you want to include this. The Lodash library as script tag, and then you can just pass some externals configuration, and Lodash will be used from CDN with your script tag from the script tag. So it's basically used from global scope. There are many options. You can pass regular expressions. Example, all React specific modules are external. You can pass a custom function, which allows you to choose at runtime. Not at runtime, at compile time. And there's a complexer configuration for if you use the UMD target. You basically can choose what is the behavior for Lodash, for CommonJS, for AMD, or if it's in the global scope, because some libraries have differences here.
And when you do this, this means you can like require or import these modules in your code.
Yes, you just require Lodash, and Webpack won't look it up in the node modules for it. Will assume it's available on the runtime at runtime in the environment. So you don't have to change your code base. You just have this configuration and still write modular ECMAScript modules or CommonJS modules in the code base. So yeah, it's not well known that Webpack has other targets than web. It can compile, in example, it can compile code for Electron. So it basically, you have a target option which can have Electron main, Electron render, and it automatically choose native modules for this and the right pattern for code splitting, for lazy loading. Yeah. And there's also a Node.js target, which we said yesterday, but no target node, target async node, which uses an async way to load chunks, and target node just uses require to load chunks. It's great because it makes the code faster in Node.js, because Node.js has a very slow and synchronous require statement, so it's basically all sequential, and if it's bundled, it's much faster because it just has to read one file, no I/O, and super fast.
Yeah, absolutely.
But it's maybe difficult. Oh, I have a to-do. Oh, so missed.
And it's a good experience to try hot module replacement with Node.js. If you have never tried it before, you should. I recommend it. It's very nice.
Okay, chunk hash. Chunk hash is a nice function to allows to opt into long-term caching. So basically give add this placeholder in some options: file name, chunk file name, output file. Output file not, but file name, and Webpack will replace it with a hash of the file. So you can just cache your files forever, and every time you recompile and the file changed, it will have a new hash. So it's basically automatically. Yeah, we had a question yesterday. Final file name can be found in the stats. If you have the problem, you need to add a script tag to the HTML file, but you don't know which hash has it at runtime. So you can export the stats of Webpack, basically with Webpack's --JSON, or there's a plugin which writes it to a file. And in the stats object, there's a mapping from chunk name to file name. Also great is if you use a HTML Webpack plugin, it will automatically use the right file name for you.
Takes care of it for you.
The records. The problem with chunk hashes is that you have to avoid that the chunks are changing, but Webpack automatically chooses module IDs for you. So if you add some module, all the module names which are numeric and sequential, maybe invalidate some vendor chunk or unwanted changes in your bundle. So there's a feature which called records, which allows you to store the mapping from module name to module ID and reuse it on the next compilation. So basically it stores a file and reuses the modules from the records file. So they never change if you have records. But the problem is you have to keep this file somewhere and pass it to the next compilation. It's maybe a bit infrastructure overhead. I can recommend a network share for storing this file, or checking to commit it is not that great. So basically a network share is the best option.
Yep.
So if you don't want to use this overhead with infrastructure, there's an alternative which doesn't create that optimized bundles, but it basically uses the module name as module ID, so it's just a string with the module name. It's also useful for debugging because you see all the names in your bundle. But the disadvantage is if you use it in production, as your customer can see your file structure of your application, so basically which files, which file names the modules are, and maybe decompile it to some inner knowledge. So it also increases the bundle size a bit because numbers are shorter than strings. But gzip, it's not that much affected because it's strings also gzip very good.
We have 60 seconds. 60 seconds.
Okay. There's an alternative, the hashed module plugin, which basically does the same but hashes the module names, which increase the bundle size a lot more, and also the gzip size, but it doesn't leak the names. So the last one is the DLL plugin, which basically allows you to does a separate compilation with some of the modules and reuse this bundle in your application bundle. So you basically do two script tags, one with a DLL bundle and one with the application bundle, and the application bundle points with a DLL reference plug into the DLL manifest, and uses modules inside that. It's great for build performance, and you can do render bundles with this idea, but there are disadvantages. You get no tree shaking, no scope heisting in the DLL bundle because every module has to be exposed to the application bundle. Here's a new example. Yeah. Okay, thanks.
Probably not, yeah. So yes, thanks.